very low, because I hope you can hear me.
Yes, I can hear you, sir.
Okay.
Yes, you can.
Okay. So it is very important for facilities managers to align their objective with the company's objective. Now, for every organization, there is what we call the purpose of that organization and what the organization intends to achieve. For example, if an organization is bringing in trailer loads of goods, maybe 1,000 every week, and that same organization is now telling, come up with a vision or an objective that, okay, we are going to be bringing 10,000 trucks of goods. It means that the facilities manager there should be able to align his objective with the organization's objective. If I was dealing with 1,000 trucks, now I'm about to deal with 10,000. It means there's going to be an expansion. There's going to be, you make provision for warehouse, for space, for where you keep these goods. So, but if an organization make that kind of objective and a facilities manager is not in alignment, you started planning for maybe 3,000, then you have already failed. So you must align your strategy with the organizational strategy. And that's why when the organization sets its objective, the facilities manager picks it up and begin to develop strategies on how to manage the assets of that organization. And managing assets, what you want to achieve is effectiveness. What you want to achieve is optimal use of that asset. What you want to also achieve is that there must be economic value to that asset. Remember, as facilities manager, year in, year out, you are supposed to come up with a plan that will save cost. If you saved 10% last year, management still wants you to save another 10% or even more in the following year. So your plan, you must be able to plan your strategy in such a way that maintenance will not gobble up your budget. Now, in maintenance strategy, all right, this is my profile. I didn't even go through it. My name is Charles Inyogbong, General Manager, Performance Management and Operation Excellence at Max-Migold. Over 30 years experience in FM. I have a CFM and a Certified Management System professional. So the objective of this course, number one, we'll understand availability and safety of systems. For you to carry out facilities management, asset management, maintenance, and all that, what are you trying to achieve? You are trying to achieve availability of that asset. You are trying to achieve that the asset is well preserved. You are also trying to achieve a reduced equipment downtime. So in this course, we are going to look at all these: equipment, availability, ensure reliability of equipment, meaning that whenever that equipment is needed to function, it functions well. Reduce maintenance time. You want to also reduce maintenance time. You don't want to always alter the core business because you want to carry out maintenance. We've seen situations where facilities managers will just come up with a maintenance schedule without carrying the occupant along. It becomes a problem. Also, reducing maintenance cost. When you look at all the strategies, you want to deploy the strategy that will reduce maintenance cost. You want to give management the strategy that they will be happy with, not the one that they will be frowned about. Ensure optimum performance of equipment. Facility maintenance will ensure what? Optimum performance of equipment. As in, you have 100% performance of that equipment. Reduce capital repairs on equipment. We know that when equipment are not well maintained according to the OEM, according to the manufacturer's specification, there's possibility of damaging that equipment, which will result to capital expenditure. So when you deploy the right strategy, you are able to reduce capital repairs on equipment. Again, it prolongs equipment life cycle. Now, we need to be very careful about this because maintenance of an equipment does not necessarily prolong the equipment life. There are some equipment that from the manufacturer is supposed to be for 10 years. And after 10 years, you need to replace that equipment. But adequate maintenance will enable you optimize that equipment lifespan. So maintenance does not prolong equipment, but it helps you to optimize the effective use of that equipment. Now, also we'll look at that the facility management reduce unplanned downtimes. We talked about, downtimes in the office, in the company, and all that. This is a very critical aspect because you don't want a situation whereby your management is doing a critical work and all of a sudden the generator is going off. It can be as simple as that, but it's a very serious matter. So you plan your maintenance in such a way that you reduce unplanned downtime and you reduce unplanned repairs. Okay, in this module, we'll look at introduction, which we talked about, and we'll look at run to failure, which is reactive maintenance. Run to failure means a kind of maintenance where you are expected to do nothing until an equipment fails. It's very funny, but you don't need to do anything for that asset. You just need to leave that asset. You only act when that asset fails. So that's run to failure. And it is a strategy, and it's a strategy that must be deployed in any facility at all if you really want to get things right. Now we have the preventive plan maintenance. The preventive plan maintenance is maintenance that involves schedule. You put your maintenance around schedule. For example, your generator, you say, okay, you can carry out services every 250 hours or every 2 months. So there's a schedule around preventive maintenance. This kind of maintenance, basically, you can get information from your manual. So with this, you can say, okay, from the manual, we are supposed to service this generator or service this equipment in every 2-3 months. Then we'll look at the next module, which is the predictive maintenance. This is very key. In fact, in facilities management, we are trying to move from run to failure, from preventive plan maintenance into predictive maintenance. The ability for you to predict when to carry out services, when to carry out maintenance. So this is very, very important. If you meet a very sound technician, a very sound generator technician, he should be able to tell you when to carry out maintenance based on his experience, based on data, based on condition assessment that generator. Then the fifth module here is reliability-centered maintenance. This is not a strategy. Remember, run to failure is a strategy. Preventive maintenance is a strategy. Predictive maintenance is a strategy that you can deploy when you are maintaining your assets. But reliability-centered maintenance is not a strategy, but it is a framework where you can choose from these three maintenance strategy, how you can mix them, how you can deploy different maintenance strategy to gain optimum results. So we are going to look at all that. Remember that as a facilities manager, you get to your facility, the first thing you want to know is your asset register. You want to know the number of assets you have in that facility, and you categorize them based on the kind of strategy that you want to deploy in maintaining the assets. So we talked a little about the introduction. Now, how do you choose a strategy? Number one, you must understand the method you want to use. Number two, you must understand the goal. What do you intend to achieve? For example, if you have a generator that you are not, because of this band 18, you have power like every day, and you see that the generator is just redundant, not working. What kind of strategy are you going to deploy for that generator? What kind of strategy? Is it going to be a run to failure? Is it going to be a preventive maintenance? Is it going to be a predictive maintenance? What kind of maintenance are you going to apply to that generator. So those are the things you look at. You look at what are the advantages. If I do run to failure, what are the advantages? If I do preventive or planned maintenance, what are the advantages? What are the disadvantages? The strategy. Then at the end, you want to evaluate the maintenance strategy. You know, for everything that you plan, there's what we call the plan, do, check, and act. When you plan, after planning, you do, which is the implementation. Then the next step will be to check. To check is to evaluate whether what you plan is delivering the kind of results that you want. Then the last one is to act. If there is a deviation from your plan, if there's a deviation from your final result, what do? You need to check. And when you check, you can now implement some kind of corrective action so that to bring you back to your plan or to your goal. It is important that there is a good understanding of how equipment fails in order to make a good choice of the most appropriate maintenance strategy. Now, as a facilities manager, if you have been in the field for a while and you are working with some equipment, you should be able to know how those equipment fail, their frequency, you know, by your experience. You should be able to know that, okay, when this thing can go bad in the next 2-3 months. So you plan based on that. So maintenance strategies is also tied to that. If I understand how my equipment fail, if I understand how my generator fails, right, I can plan my strategy on how to maintain it, to deal with that pain, to deal with that failure, to close that gap. So by experience, you should be able to know how your equipment fails so that you can deploy the right maintenance strategy. Remember, we are looking at 3 maintenance strategy, which is the run to failure, do nothing until the equipment fails. That's where you act. You don't go around servicing the equipment. You don't go around cleaning the equipment. You wait until it goes bad before you fix. Then we have the preventive plan maintenance. Those are equipment that are under schedule, equipment with moving parts, equipment with consumable, replaceable parts. Those equipment are under the preventive maintenance. Then we have the predictive maintenance, equipment that you really cannot tell their failure mode. So the best thing is to monitor the condition of the equipment, and at the end, you can decide whether to carry out maintenance. Criteria for choosing a maintenance plan include allocation of available resources. Now, resources is very important. I've seen facilities manager, they start a maintenance work without putting on ground the necessary resources. You need the technical people to be on ground. You need the material resources, what you need to change. So there must be availability of resources for you to choose the right maintenance strategy. Organizational maintenance process. Now, for this, there's some organization, before you get fund, it goes through series of approval levels. So for you to carry out maintenance so that you won't cause any gap in your process, you must understand how your organization disburse fund. If you pass through your supervisor and your supervisor is need to pass through his supervisor before it gets to the MD, if it's a company that the MD need to sign before money is released, then you have to take all that into consideration before starting a maintenance. So you need to understand. I've seen a situation where facilities managers are in trouble because they don't understand. They fail to understand how fund is being released for maintenance work. So you can just, put the entire occupant in a fix when you don't have the money to carry out the repairs. Selection of technology. In facilities management, there are so many technologies in carrying out facilities management, but you need to select the right technology. Sometimes people come up with technology that are so expensive. When it comes to the CMMS, the computerized maintenance management system, it is very, very expensive. So for small companies, they cannot afford that. But if you are in multinational companies that have that capacity, they can. So when you are deploying your maintenance strategy, you need to look at okay, this technology I'm about to introduce, is this something my company can adopt? Do we have the fund to run that technology? Adoption of already existing technology. If you have existing technology, it's important to adopt it, to reduce costs. Generally, what we are saying is that in choosing a maintenance strategy, you need to look at all these things. You need to look at the skills of your personnel. Do they have the right skill? Do you want to bring a carpenter to go and do to go and service an AC? So things like that are very important. Then the quality of service. This is very, very important because what we do is more of subjective quality assessment. It is not objective like the manufacturing company, where if I say I'm manufacturing bread now, for example, I have the dimension of the bread. So it's just for me to measure the dimension and write it down. If it is lower than my measurement, I can now say that doesn't meet the criteria. But in facilities management, it's more of perception. You do your work and you expect the people the occupants to, assess you. And sometimes if the person is not happy with you, no matter what you do, no matter the excellence you put in that job, the person will still rate you low. I've seen situation where, a technician just walked into an office, went straight to the AC, serviced the AC, did a good job and left. And when the occupant was asked, give us your perception of what my men did. He said, don't mind that guy. He doesn't know anything. Something like that. So because the technician entered the office, he didn't greet, he just went, did his work and left. So it is more of perception when it comes to facilities management. When we go into quality management in facilities management, we will talk more about that. So quality is very important. The way you close out jobs, the promptness of closing out of jobs. There are some jobs that, if it is an emergency job, your SLA can tell you that, okay, you must close out this job in 3 hours. So you must stick to that SLA. In fact, you try as much as possible to exceed SLA. Then, like I said, the customers, they are very important. The occupants, they are very important. The clients you are servicing, they are very, very important because these are the people that will rate you at the end of the day. Common challenges of maintenance strategies. Number one, lack of understanding maintenance strategy elements. When you don't understand maintenance strategy elements, there is no way you can deploy the right maintenance strategy. For example, you want to maintain a generator. Remember that a generator is an equipment that has moving parts. So when there's moving parts, one of the elements that will be affecting that generator will be friction, and you have wear and tear. So when you have that understanding, you will know that the best strategy to deploy for a generator is the preventive maintenance that deals with schedule. Now, for smaller equipment, say the light bulb and others, they are very cheap. You can't begin to put a routine maintenance around the light bulb because you'll be spending so much in terms of personnel, in terms of resources, in terms of time. Otherwise, you would have just, replaced the bulb, go to the market, get a new bulb and replace it. It will cut off all other expenses. So those are the elements you look at before you, deploy a maintenance strategy. Low budget allocation. We said this before, that when it comes to facility, organizations devote much money to it. Then inadequate maintenance resources, ineffectiveness of maintenance activity, misalignment of maintenance strategy. If the objective of the organization is not in line with your own facility management objective, the problem. Then we have inadequate maintenance planning. Maintenance goes hand in hand with an organization's objective. And so there must be a clear understanding of maintenance objectives to ensure proper allocation of maintenance resources. So you must understand your organization's objective. If your organization is expanding, oh, we want to recruit more people, we want to recruit more of the Gen Z people, what do you want to do? You want to bring in smart workstation, that will meet the need of these guys that are being employed. We want to expand. We want to build more offices. You need to plan towards that. You need to look at, the utilities. Do we have enough that we go around? So you must understand your organization's objective. If organization is telling you that, in the next 6 months, we are going to replace this generator. And when you are now writing your maintenance plan, you are now putting in the maintenance plan that you are going to maintain the generator for 2 years. You are in misalignment with what your organization is doing. In fact, you don't even know what you're doing. So your maintenance plan must be in alignment. So sometimes I advise facilities managers to try to meet your management and say, what do we intend to do this year? Do we have any major expansion? Do we have any projects? So that you can plan in alignment with the company's goal. All right. Before we proceed, any question? Any question? All right, we'll take the first mode, the run to failure or the reactive maintenance. Like I said before, the run to failure maintenance is action taken to repair equipment after failure. It is important to know here that for equipment in this category, you don't have to put it under preventive maintenance. In fact, you don't touch equipment like that. For example, like I said, your water pump, your pumping machine, right? Equipment like that should be kept under run to failure. As in, you don't do anything about it. You only act when it goes bad. The best you can do for that pumping machine is to have a replacement on ground so that you can, replace when it fails, a backup pump. So equipment like that, you don't need to do anything at all. So if I see your maintenance plan and I'm seeing that for the boreholes, for the pumps, you want to carry out routine maintenance every 2 weeks on the pump, then I'll know that you are not deploying the right strategy here. Restoring equipment intended function when it fails. So when equipment fails, you restore it back to function. It can be cost effective for small equipment. Now, this kind of equipment or asset, this strategy is cost effective for small equipment. Like we said, the pumping machine, the light bulb, the refrigerator, the water dispenser, those equipments, this strategy is cost effective. So for those equipment, you can't say you want to put a routine maintenance around a refrigerator. It won't work, right? Then we have very costly for complex and critical equipment. Now, for complex and critical equipment, it's very costly, but there's really nothing you can do. For example, the transformer. The transformer is a complex equipment. I've not seen anybody that carries out, any kind of servicing or maintenance on a transformer. So what do you do for such an equipment? You leave it. When it goes bad, then you get the subject matter expert to come and fix it. So for equipment that are complex, it's very critical. And of course, if a transformer goes bad, then you need to pay, you need to spend so much, to fix it. Reactive maintenance has a philosophy of repair equipment when it breaks down. If it doesn't break down, then don't fix it. So that's the idea. If you look at your facility today, I want to tell you that about 90% of the assets in your facility fall under this run to failure maintenance strategy. Because the main ones that can go under preventive maintenance can be maybe the generator, the AC, what else there, So those are the ones that you put under the preventive maintenance. But the rest of the things you have in your facility, about 90% of them, fall under the run to failure maintenance strategy. And that's why when an FM brings a plan to me and I'm seeing that 60% of the asset in the facility is under run to failure, or 50% is under preventive maintenance, I just knew immediately that there's an error in that plan. And that kind of plan cannot fly, when you take it to management for approval. So let's just have that understanding. You can even look in your homes, just look around. You see that nearly everything is under run to failure. What you have under preventive maintenance might just be your AC and maybe your generator and what else? But your fan is under run to failure. Nobody puts a maintenance schedule around a ceiling fan. Nobody puts a maintenance schedule around refrigerator, So those are run to failure. When they go, when there's a fault, you go, you fix, and you restore back, to functionality. All right, elements of reactive maintenance. We've said it before, respond to fault cause, identify the cause of system failure, localize and isolate the problem, disassemble the system, remove failed part or component, repair or replace the part or component, reassemble the system, verify the condition of system, and create a record. Very important. For every maintenance activity you are carrying out, you must create a record, because at the end of the day, that's what you use, to get your work done, your payments. All right. Reactive maintenance is actually present in all maintenance strategies, as failure is not perfectly predicted, and also equipment still break down even after maintenance action has been performed. What this is trying to tell us is that, reactive maintenance is present in every. In fact, even if you are servicing your generator every month, at the end of the day, you'll still be having one reactive maintenance to do on that generator, because failure will not even tell you when it's for. But the good thing is that for other maintenance strategy, it can reduce that sudden failure. You can reduce the failure rate to a very low rate. Now we have the advantages and the disadvantages. You take your time to go through them. The advantages for a run to failure maintenance strategy is that it requires minimal staff. Yes, for you to change bulb, you just need one technician to go and change it. So it requires minimal staff, initial low cost. Then we have the little demand on maintenance planning. So when you are planning for run to failure, you have little demand. You don't think it too much. There's no thinking about it. You just know that for every bulb in my facility, I have in store critical spare that I can use in replacing any bad bulb. It's as simple as that. For my pumping machine, I have a backup pump. If I don't have a backup pump, I'll plan, I can just get the cost of a backup pump, put it in my budget, and send it out for approval. So you don't think too much about it. You just know that it's all about replacement. All right, we have disadvantages. It increase in labor cost. It increase in repair cost. In this case, when you are monitoring your budget, because you didn't plan for reactive maintenance, you didn't plan for emergency. If you are having this kind of maintenance often, it will affect your budget, because your budget is only based on the fixed cost and maybe a predicted variable cost, which will cover for any emergency, any unplanned activity. But if you have it more frequently, you see that you will exhaust all you have for variable costs. So it is important to reduce the number of reactive maintenance so that we don't impact negatively on our budget. Staff resources not efficiently used. You have staff, but you can't use them. Equipment not reliable. Equipment under this maintenance strategy, they are not reliable. Frequent equipment downtime, difficulty in controlling budget. Like I said before, it's very difficult to control budget if you have so much reactive maintenance. Then reduced life expectancy of equipment. initiate capital cost investment, not initial capital cost investment, not maximize. Inefficient use of resources, interference with planned work. So just go through all the disadvantages of run to failure. So even though it is a maintenance strategy that must be adopted, you also need to look at how it impacts your bottom line. If you have so much reactive maintenance, it will impact negatively on your budget. In fact, it will move from your variable cost and enter into your fixed cost. So that is something we need to watch out. Now, let's look at preventive maintenance. Preventive maintenance is maintenance performed as scheduled interval, at scheduled interval. Like I said, most equipment come with their manufacturer manual. So from the manufacturer manual, you'll be able to see the schedule of maintenance. So you can use that as your first go-to when it comes to maintenance. But as you maintain that equipment with experience, you can now decide on how you want to, you can change, the maintenance pattern so that it will be more effective and more cost effective for you. So the first place you want to start with your maintenance, your manual. Then from your manual, after using it for a time with experience, you can now do a kind of modifying of your maintenance plan so that you get best results. Maintenance performed irrespective of failure. So preventive maintenance, whether there is failure or not, you need to carry out maintenance. And that is one disadvantage of preventive maintenance. For outsourced services, maybe you outsource your generator to a vendor to service. And on the agreement is that the vendor needs to come every 2 months to come and service your generator, right? It means that whether the equipment is still okay or not, because of that agreement, the vendor will come and still carry out maintenance. I've seen situations whereby you look at the oil, the viscosity is still good. You look at the parts, the belt, everything is still good. But because there's an agreement that we need to service every 2 months, you need to do that. You must stick with the agreement. So that way, maintenance is performed irrespective of failure. So you spend more money. Otherwise, if it's something you could control, you will say, okay, you carry out a test on the oil. You see that, oh, the oil still has, the viscosity is still good. You say, let's continue to use, let's give it another mileage. By that, you have reduced costs. But in preventive plant maintenance, no way. Maintenance is performed irrespective of what? Of failure. Measure taken to ensure equipment function. So one advantage is that you take this measure to ensure that equipment function. If you have a good routine maintenance, I mean, if your compliance to preventive maintenance is very high, say 90%, 100%, you see that you increase the functionality of that equipment and you reduce the downtime. Adopt a time-based or a run-based approach. So this kind of maintenance strategy adopts what? A time-based. It can be 2 months, it can be 3 hours, it can be 4 hours, or a run rate. For example, your generator, for a good maintenance of a benchmark for maintaining generator can just be 250 hours run. So after every 250 hours, when you carry out servicing on that generator. So it adopts a time base, which can be, okay, every 2 months, or a run base, which can be every 200 or 250 hours before you carry out servicing. Based on replacing equipment after long use. So this also is based on replacing equipment. Like I said, this kind of maintenance is applies to equipment that have moving parts that are subject to wear and tear, friction, and all that. So when that happens, you see that what you need to do is to change that particular part of the equipment that is wearing. Now, preventive maintenance seeks to reduce unplanned downtime and repair cost, but it may not always dictate failure before it occurs. Now, like I said, preventive maintenance seek to do what? Reduce unplanned downtime and repair costs. But again, it does not dictate failure before it occurs. So no matter how you carry out preventive maintenance, you can finish preventive maintenance now on your generator, on your AC. Immediately you leave the place, before you know it, you are being called again. The occupant is calling you that the AC you just serviced now is malfunctioning. So that's why you're saying that preventive maintenance does not really dictate, fault before it occurs, but it gives you that mileage. It gives you that comfort that, okay, it will reduce the unplanned downtime and also reduce costs. So elements of preventive maintenance. Number one is component reliability. When you carry out preventive maintenance on an asset, on equipment, you have component reliability. And reliability is very important. In fact, it is part of the metrics that is used in measuring performance when it comes to facilities management. You see, what's the percentage compliance to preventive maintenance. They want to check you based on that. They want to check how often you have downtime, how many failures you have from that generator in a month. So preventive maintenance ensure that components of that asset to some level is reliable. All right. Another element is manufacturer's specification. So like I said before, for you to carry out maintenance of an equipment, the best is for you first to look at the manufacturer's specification. That way you will understand how to carry out maintenance on that equipment. That's one. Then two, you'll be able to claim warranty. You claim your warranty in case that equipment fails. But if you do not follow the manufacturer's specification, there's possibility that you cannot claim warranty, because when they come, when you want to claim, they'll say, let me see your maintenance record. And they want to see if you followed the manufacturer's specification. Acceptable standard, industry best practice. You follow acceptable standard, like I said, for generators, that good new generator, you want to run it for 250 hours before servicing, which is best practice. But if you have very old generators, it's better you put it around 200 hours so that, it will reduce the downtime, unplanned downtime. Keeping equipment maintenance records. So one of the good thing about preventive maintenance is that you ensure that you keep equipment maintenance records. Like I said, this is one of the tools you use as a payment tool to get your payment from your clients. You also use this to claim your warranty. You also use this to show your clients the kind of work that you've done. Especially when you go for a business review, they want to look at all this kind of record to see if you are actually doing what was agreed. Scheduling equipment replacement at the end of its useful life. So preventive maintenance can help you determine when to dispose an equipment. For example, you use the equipment for like 10 years. With good preventive maintenance, you should be able to know the equipment failure mode. So with that failure mode, you should be able to know that, this equipment is reaching the end of its useful life. And when you now look at the cost of maintaining that equipment and the cost of replacing that equipment, when you compare these two, it's easy for you to see that when the cost of maintenance is so much, almost like the cost of replacement, then you can take a decision. So preventive maintenance helps you to schedule equipment for replacement. All right. And also it helps you to maintain equipment inventory, as in the critical spares. For you to run this kind of strategy, for you to deploy this kind of strategy in your maintenance plan, you must put a plan or put provision for critical spares, critical components. You must have a store where you have all the critical spares, so that when you are deploying this maintenance strategy, when you need to change things, you can just go to the store, take whatever you want, and do the work. All right. Analyzing equipment requirements, like we've talked about the specification of the operations, we talk specification of equipment performance. So one way to check, because after deploying a plan, it is necessary for you to monitor the plan and then evaluate the plan. Why are you evaluating the plan? You are evaluating the plan to see whether your plan, the goal or your objective is being met. Because if you have a plan and you don't evaluate that plan, at the end of the day, you may not meet your goal. So it's important for you to, when you put a plan, when you draw up a maintenance plan, you need to monitor that plan. At the end, you evaluate that plan to check if it meets your objective. All right. Any question at this point before we move on?
No, sir.
All right. And when you are evaluating your plan, you are reviewing equipment maintenance.
I have a question.
Question? Is somebody saying something? Okay. Reviewing equipment maintenance records of inspection.
Sorry, sir. Good afternoon.
Good afternoon.
Yes, I just want to seek clarification. Earlier, you mentioned among the equipment that do not require maintenance, and your among those expensive equipment or do not require maintenance. Something you mentioned transformer. I thought we normally carry out maintenance like twice a year on a transformer. Just want you to help me clarify that.
Okay, so who carries out the maintenance on the transformer?
Normally we call in NEPA officials or PHCN.
Okay, so that's what I'm saying. You know, for equipment like that, they are critical equipment.
Yes.
Number one, you cannot say you want to put a routine maintenance around it, except you have the subject matter expert to do the maintenance. So, because you don't have, if you don't, NEPA is there, you call them to come and fix it, right? But in a situation where you don't have the subject matter expert, what you do, you just leave the equipment to run to failure.
Okay,
I don't know if you understand.
Yeah, it's clear now. It's clear.
Okay.
Thank you.
Yeah. All right, let's move on. I need you to read the advantages and the disadvantages. Advantages of plant maintenance: reduce the risk of unexpected equipment failure. It reduces the risk of unexpected equipment failure. If you are servicing a generator every month, there's possibility that as you are servicing, it will improve the availability of that generator. So it will reduce the risk of unexpected equipment downtime. Optimum performance of equipment. It gives optimum performance of equipment when you carry out the necessary maintenance. It's just like the car we drive, you know. If we maintain our cars very well, you see that it gives us optimum performance. Now, reduce equipment downtime, correct? Fewer repair emergencies, lower unplanned equipment downtime, extend equipment useful life. That is, you have optimum use of the useful life of that equipment, keeps equipment in good working condition. And equipment that is well maintained is always in good working condition. And you know that not just the functionality of that equipment, but the safety of that equipment is very important. You don't want to come to, use an equipment or and you are receiving any kind of incident, or that equipment is posing some kind of hazard. So when equipment is well maintained, it keeps the equipment safe. Improvement in system reliability. That is, whenever you need that equipment, it will work. I remember when I was with SPDC in Port Harcourt, we have, because of the kind of server they have there, because of the kind of database they have there, power is like 24 hours, there's no power cut at any time. If there's any power cuts, immediately they have the turbine, they have power from national grid, they also have their generator. So there is no way power can go off for 30 seconds. It's too much. So what they do is that their generator, even though they don't use it, they use their turbine, but they make sure that they carry out availability check on that, availability test on that generator every week. They will just turn on the generator and it will run for hours without even putting load on it, just to make sure that in case turbine fails and power from national grid fails, the generator will be, reliable. So some organization will go to that extent to ensure that their assets are very reliable and they function once they are needed. Decrease in cost of parts or replacement with effective preventive maintenance. You see that you decrease the cost of part replacement, then better inventory management. With this, you have your store, you have your inventory, you have your critical spares, and you can access them whenever you need them. That way, you give customer a very good experience of your service, and everybody is happy. Now, note that cost savings of about 12% to 18% when you compare these to reactive maintenance. So if in your facility you say, okay, let me do reactive maintenance, a run to failure maintenance all through, and you decide to do in another facility a preventive maintenance all through, you see that you will save costs of about 12 to 18% using the preventive maintenance. But then there are disadvantages. Number one is higher demand of resources. You must have competent people. You must have resources. There must be fund. There must be critical spares must be on ground for you to take care of these maintenance work. Then high maintenance costs. No consideration given to technical condition. We said it before. No consideration given to technical condition. The thing is that since it's a scheduled maintenance, whether there is fault or not, whether the equipment is still performing well or not, we will carry out the maintenance. Whether the parts, the filter is still okay, we have to replace it. So there's no consideration given to technical conditions. We don't check the condition, you just go, you carry out your maintenance. Then maintenance activities are not prioritized. You cannot prioritize your maintenance. You cannot say, okay, this generator, instead of doing it as when due at the end of the month, let us move it to the next month. No, you won't do that, because an agreement is that the generator will be serviced every 2 months or every 250 hours. So you don't prioritize. You just need to do, just like when you want to fumigate, external fumigation, you do it every quarter. And maybe because it was dry season and there's not so much mosquito and everything, and you want to say, oh, because there's no mosquitoes and everything, let me push the fumigation to another quarter. You can't do that. You always stick to the maintenance plan. Equipment still fails after maintenance. Yes, we know that equipment still fails after you carry out maintenance. Then unnecessary maintenance. Sometimes the maintenance activity is not necessary, but because you have a plan, then you need to follow the plan that you have. All right, that's so much for preventive maintenance. We are going to take a break. And when we come back, we are going to go into predictive maintenance. But while we are on break, Barakat, you can share those questions so that we can start seeing response. All right, we'll come back in the next 5 minutes, same 6 o'clock. We'll be back. All right, welcome back. One of the feedback I've just got is that it's like I'm rushing the class. I'll try to slow down so that we can follow, especially those that are taking notes. All right, let's continue. Hello, Barakat. Did you post the questions?
Okay, not yet, sir. Actually, I got knocked out as well. The internet is affected from my end. I'm just going to drop it now.
Okay. Okay. So any questions before we proceed? Can we see the question on the screen? Hello, can we see the question on the screen?
No question, sir.
Okay.
No question, sir.
Barakat, how are they going to see it?
I've seen the question, there's the question on the screen.
I've launched
Okay.
I've launched the question, the poll already, so I expect them to see it pop up on their screen now.
Okay, so from their end, they can access the poll, right?
Yes, yes, it should pop up on their screen now.
It's already popped up on the screen, so.
You might have, sorry, you might have to log out and log in then. That should be your network.
But they can be doing this on the background now, right?
Yes, you can do it in the background.
Okay. Okay, so we'll just continue. First question there says, run to failure is a strategy in which no routine maintenance tasks are performed on equipment. True or false? Who can answer that? Run to failure is a strategy in which no routine maintenance tasks are performed on the equipment. True or false?
True, sir. True, sir.
Yeah, that's correct. True, because there's no routine maintenance tasks performed on the equipment. Then number two said the only maintenance performed on equipment under the run to failure strategy is what? We have preventive maintenance, we have corrective maintenance.
Corrective maintenance.
Corrective
maintenance.
Good. So it's a very simple one. So this is just to give us, an understanding of these strategies. Like I said, run to failure maintenance strategy is one strategy that we feel maybe is like a wrong strategy, but it's not a wrong strategy. It's a strategy that you use in getting effective use of your facility while your eyes are on the bottom line of the organization, whereby you are looking at cost and how you are saving cost. All right. All right. Predictive maintenance. We've talked about run to failure, which means do nothing until there is failure. Do not do it, as in do nothing until there's a failure. Act only when there is a failure. Then we've looked at preventive maintenance, which talks about schedule, which talks about frequency, which talks about the condition or elements of the assets. When you want to deploy a preventive maintenance, you also need to look at, the frequency. You need to look at, what kind of asset is it, asset with moving parts, for you to deploy a preventive maintenance strategy. And now I want to look at the predictive maintenance strategy. Predictive maintenance strategy is a strategy that involves condition assessment, condition monitoring. Now, I said something earlier that when you are working, when you have a very good technician, maybe a generator technician, or maybe generally a plumbing technician, because of his experience with that equipment, he can tell you because of this sound I'm hearing from this pump or from this generator making this sound, we need to carry out servicing on the generator. That decision is based on what? Experience. It is based on the long time, operation of that equipment. So sometimes based on our experience with a particular equipment, with a particular asset, with the facility, we can predict when to carry out services or when to carry out maintenance of that equipment. For example, condition monitoring, as in there's some generator you have that has a display panel where you are seeing everything that is going on in that generator. It's just like the car you are driving to. When you look at the dashboard, there are some certain light signals that you see on your dashboard, and it will inform you that something is wrong. You need to do something, right? If the gear light, if the engine light is blinking, you need to know that you need to maybe service the generator or check what is going the car, or check what is going on. So this kind of maintenance is based on prediction. And how do you predict anything? Is when you do a condition monitoring of that equipment. The process of evaluating equipment condition, and it is data driven. So for you, during monitoring, what do you do during monitoring? What you do during monitoring is generating data. You generate data during monitoring. And after generating the data, you analyze the data, you evaluate the data, and then you give a kind of conclusion from the data that you have generated and analyzed. So predictive maintenance is all about condition monitoring, and it is suited for critical and complex equipment. We said something before about critical and complex equipment. For example, we said something about the transformer. It is a critical and complex equipment. It means that if you have other equipment that you can use in monitoring the condition of the transformer, you can predict when to carry out maintenance on that transformer instead of waiting for it to go bad before you fix. So this kind of maintenance is all about monitoring condition, monitoring, like meter reading on your generator, checking things, and when you get your data, you analyze and you decide on what to do. Performing maintenance on basis of predicted defects. These things are statics, they're specific points in time. So they are mainly static equipment. And at the end of the day, when you get your data, you can now compare and say, okay, based on this standard, we can carry out maintenance. Maintenance is not carried out based on predetermined dates, but based on the actual condition of equipment. This is a very good maintenance strategy, which helps you carry out maintenance as when due. So you don't do it, you do it as when due, not like preventive maintenance where you must do it, whether the equipment is faulty or not, whether it is performing or not, you must do it. But this one, you monitor the condition and you carry out maintenance as at when due and when it is needed. This implies that maintenance is performed at the ideal time and resources not wasted on unnecessary work. Convenient scheduling. So with this kind of maintenance strategy, you can conveniently schedule your maintenance. You can just wake up and tell your occupants, oh, by next week, so time, we want to carry out maintenance because from our record, we see that we need to carry out a maintenance. So you plan your maintenance very well and everybody is carried along. All right. So what are the tools we use in this kind of maintenance? What are the tools? You use something like the sensors, use the meters, you have the videos and other tools. These tools do what? They help us to monitor the condition of that asset. For example, I said something about the new kind of generators that we have now. You see that generator have a display panel where it will be telling you the viscosity of the oil, the level of the oil, and many other parameters. From that display panel, you'll be able to decide whether to carry out services or not. So this kind of predictive, this kind of maintenance strategy will help you, decide beforehand when to carry out maintenance. And if you look at it, they also include vibration analysis, thermography, viscosity testing. Like I said, for the oil, you do it viscosity testing, the sensor, the meter, the videos, and other form of analytical method that you use in predicting whether to carry out in maintenance. But for this kind of equipment, I know in our own, this region, I mean, we don't really have equipment in this category. But when you go to very high level organization where they need things to run properly, they have monitoring sensors that dictate when to carry out a particular maintenance on a particular equipment. So from this analysis, you see that predictive maintenance helps us to reduce cost so much that you have so much that it will help you reduce cost in such a way that you are using the minimal cost to do that maintenance. But there's a downside to this, because what you need to get the information, the data, monitoring and other things, you need other equipment. For example, if you have a generator and you want to monitor the condition of that generator, you need to buy things like sensor, you need to buy things like vibration analysis. So that money that you would have saved during maintenance, you would have spent them on getting other equipment. Why use predictive maintenance? Predictive maintenance allows planning for and scheduling of corrective maintenance. So with predictive maintenance, you can plan for and schedule corrective maintenance, as in the equipment will still be in use and you are doing your maintenance. People will still be working and you still carry out your maintenance. Prevent unplanned failure of equipment. Yes, this prevents unplanned failure of equipment. Reduce purchase of spare parts. Now, there are some parts that can still be useful, but if you are deploying a preventive maintenance strategy, because you need to change that part every 2 months, you have to change it, whether the part is still functioning, whether the part is still in good condition. But for a predictive maintenance, you're able to know, you will know whether to change that part you continue to use. Reduce maintenance costs, improvement in maintenance planning, increase system availability and reliability. So this is a very important strategy because it's increased availability. I said something about how Shell do with their generator. They want 100% availability, 100% reliability. With predictive maintenance, you know when the equipment will fail. So instead of waiting for the equipment to fail, you carry out your maintenance. That way, there is 100% reliability. Maintenance is performed while equipment is still in service. That is, an equipment can still be, is still in use, and you are carrying out maintenance. Eliminate or reduce service disruption. So with this kind of maintenance strategy, you almost eliminate service disruption. You almost eliminate service disruption. But one thing is sure, you will definitely reduce service disruption. Allows for early detection of problems. So with a predictive maintenance, you can detect early, problems that are inherent in an asset. Okay, maintenance is performed when it is necessary or needed, which is in contrast with preventive maintenance, when equipment is maintained, whether it is needed or not. So this is the difference between the predictive maintenance and the preventive maintenance. Maintenance is performed when it is necessary for predictive maintenance. Therefore, preventive maintenance is done whether it is needed or not. So that way you can see the advantage, clearly. You can see how, if I do maintenance, whether it is needed or not, definitely I'll spend more money. But if I do maintenance when it is actually needed, then I will spend less money. All right, these are the advantages. Advantages: fewer breakdowns, reduce equipment downtime, increase in production, increase in productivity. If you are in a facility where you have power 24/7, the AC working 24/7, the lighting system is perfect, everything, it will increase your productivity. I remember those days, people come to the office when we were in Shell, people come to the office and they don't want to go because the environment is conducive, power is stable, AC is running and everything. So it increased productivity. But when all these things are not working well, it reduces productivity. Increased component operational life. So the components would be, you use the components you optimize the operational life of the components. Allows for preemptive corrective action. You can decide when to carry out corrective action at your own pace. And if you are working in a place that is SLA driven, as in SLA, in closing out of job, if the whole system is SLA driven, with this kind of maintenance strategy, you will always exceed SLA. You will always meet and exceed your SLA because you decide when to carry out, corrective action, when to carry out corrective maintenance, when to do the things you need to do. Decrease in cost for parts and labor, better product quality, improve worker and environment safety. Now, one of the disadvantages of this kind of maintenance is the high initial startup costs. For you to deploy a predictive maintenance in your facility, you need high initial startup costs. And where do you spend that money? It is in acquiring monitoring devices, acquiring the things you use to monitor the assets, acquiring the software or the system used to generate data about that your assets. So for you to acquire those software, to acquire those devices, you see that you're spending so much money. So you have high initial startup costs. Another disadvantage is that saving potential not readily seen. No matter how you want to speak, convince your management, they are always looking at the bottom line. They are looking at the startup cost. How much do we need to implement this maintenance strategy? And what is the savings, the cost savings potential? Let us see it before we decide. So this kind of maintenance strategy can only, the savings potential of this kind of maintenance strategy can only be seen in a very long time, as in when you put it in a long-term basis, maybe 5 years, 6 years, 10 years. But management will not want to look at that. They want to see the immediate returns, the immediate savings potential of that strategy. Increased investment in the diagnostic device. Like I said, the monitoring devices, there must be, so much investment in that. Then increased investment in staff training, because apart from the equipment you want to maintain, you need to train the staff to be able to read the data, to be able to use those monitoring devices, read the data, analyze the data, and be able to come to a conclusion based on the data received. So you need training. So deploying this maintenance strategy. So when you are writing your plan, you are developing your maintenance plan, and you say, okay, we want to do predictive maintenance for certain equipment. Management want to also look at, apart from the maintenance itself, how much are we going to spend on the diagnostic equipment? How much are we going to spend on the sensor, the meters, and all that? So you need to show how that will translate into cost savings, which is never easy. So that's the disadvantage of predictive maintenance. And of course, you need to see how you are going to train the staff. Because at the end of the day, even when you bring all those equipment, the diagnostic equipment, the sensor and everything, and your technicians, they cannot read it, they cannot apply it, they cannot read it, they cannot implement it, then it is a waste of resources. All right. So we've looked at run to failure maintenance, we looked at preventive maintenance, we look at the predictive maintenance. Now we want to look at the reliability-centered maintenance. Like I said when we started, reliability-centered maintenance is not a strategy, but it's a framework where you, as the facilities manager, right, you look at the 3 different strategies in facilities management for your assets, and you try to see how you can mismatch it so that at the end of the day, you get a highly functional facility, which also reflects in the economic situation. I'm talking about cost. So when you look at the framework, you now pick the run to failure maintenance, you pick the predictive maintenance and the preventive maintenance. You decide on the assets you want to launch, you want to categorize your assets to. Then you now deploy. At the end of the day, you are looking at how this will affect your facility, your maintenance goal, and also how it will meet your company's funding in terms of budgets. So that's what reliability-centered maintenance does. It helps you to mix match and get everything working with, get everything working to ensure that the functionality is there and also the cost saving is also achieved. The basic philosophy of the RCM is that decision on maintenance activity should be based on systems maintenance requirements supported by economic and technical premises. So you look at the maintenance requirements. What are the maintenance requirements? From the manual, from the manufacturer manual, you look at the requirements and you implement. Like I said before, when you use manual to draw up your maintenance plan, you can only use that for, like 2-3 years. After that, it is necessary for you to bring in your own initiative in creating your maintenance plan, because you've stayed with that equipment. You know how the equipment works. You know the failure mode of that equipment. You know the routine, the maintenance frequency of that equipment. Now you can use that information and create your own customized maintenance plan. And that's when you bring in the RCM. You look at, okay, since we are not using the generator frequently because we have 24 hours power supply from the national grid, why would I put this generator under preventive maintenance? Why not put it under predictive maintenance or under the run to failure maintenance, or reduce the maintenance cycle significantly so that you reduce the cost you are spending on that generator? So these are the ways you look at your assets. So reliability center maintenance brings you now, as a facilities manager, it gives you that freedom to do what? To bring your own initiative to optimize your facility. So at the end of the day, you are looking at, what did I spend this year on maintenance, last year on maintenance? What am I spending this year? And you want to show clearly the difference, the reduction in maintenance cost. Okay, combination of more than one maintenance strategy. And again, some equipment, you can use more than one maintenance strategy for that equipment. You can use the run to failure for that equipment. You can still use the predictive maintenance for that equipment. What are you trying to do? Is to ensure that you reduce costs while getting the equipment functioning very well. Optimization of a system maintainability, consider system component condition and its impact on system performance. Determines the most effective maintenance strategy. With this, you'll be able to determine the most effective maintenance strategy. By the time you combine strategy on a particular equipment, at the end, you'll be able to know that, oh, this particular strategy is best for this equipment. Remember, why you are doing all this is to show management that you are able to reduce maintenance costs. Because the biggest pressure burden on management, apart from salary, is facility management, is maintenance of facility. So you want to show how you can reduce costs, optimize what you have, and get the best out of it all. Maintenance activities are characterized by use of maintenance lifecycle view, continuous process improvement. So as you are implementing your maintenance, you are also doing what we call the continual improvement. In a system, in a process, in facilities management generally, we want to see continual improvement in what you are doing. All right. Use of root cause and failure analysis. Again, the reliability center maintenance help you to do what we call root cause analysis. When you have a failure, we see many times that facilities manager just go, they fix the fault, and that's it. But what is required now is that you do a root cause analysis of that failure to find out what is the root cause of that failure, and you deal with that root cause. Because when you deal with the root cause, it is almost certain that that thing will not happen again. And that's where deploying a reliability center maintenance helps you as a facilities manager to look at all these aspects. Like we said, reliability center maintenance is a framework that enables the definition of a complete maintenance regime, ensures that the assets continue to do what their users require in the present operating context. It's a systematic approach to evaluate a facility's equipment and resources to best meet the two and result in high degree of facility reliability and cost effectiveness. So like we said before, reliability center, two things are very important when you are deploying this framework. Number one, there must be a high degree of facility availability, facility reliability, and then cost effectiveness. So no matter what you are doing, we want to see that you have reduced cost from where you are coming from last year, and there's a reduction in cost this year. That's the only way you can stand before management and it will be like you are really saying something. All right. This framework is highly reliant on predictive maintenance. So for you to get this a very good cost-effective strategy by deploying a reliability center maintenance, almost 100% of it should be based on what? On predictive maintenance, but that cannot happen because we do not, most establishments don't have the equipment for predictive maintenance. But this reliability center maintenance, if you can deploy a predictive maintenance in it, then you have what we call better advantage. You have better advantage in terms of your cost, your spendings. So reliability center maintenance, let's look at this table. It shows the reliability hierarchy. Now we said something about corrective elements, which includes small parts and equipment. So when you are deploying a reliability center maintenance, for every small part and equipment, you categorize that under the corrective elements. For equipment that have, moving parts that is subject to wear and tear, you know that definitely that should be categorized under preventive maintenance. Then for equipment that have random failure pattern, you can't really tell their failure pattern. You know, for some equipment, you can tell that after 2 weeks, it will fail. But for equipment that you don't really know, it has a very random failure pattern, then you can now place that under predictive maintenance. Remember, we are using the reliability center framework to place our equipment, to place our assets under the different maintenance strategy. For non-critical equipment, equipment that are not critical, equipment that even if they are faulty, they don't affect your core business, right? Even if they are faulty, they don't affect your core business. Such equipment, you put them under the corrective elements. Then equipment that has consumable, For example, you need to change belts, you need to change, what's it called, filter. You need to change one thing or the other. You put it under preventive maintenance so that you know you have a schedule around it, so that when you carry out your maintenance based on schedule, you'll be able to change those consumables. Now, for critical equipment that you necessarily cannot touch them. If you start to work on them, you might even create more problem. You have them under predictive maintenance. So generally, the reliability-centered maintenance is showing us how to categorize our equipment, how to maintain our equipment based on their element, based on the kind of their nature. For example, a redundant equipment that you hardly use, are you going to put a preventive maintenance around that kind of equipment? No. You must put that under a run to failure maintenance strategy or a predictive maintenance strategy. All right. So quickly go through the advantages of reliability-centered maintenance. But before we take this slide, any question? Anybody want to, ask question or contributions? Any question or contribution?
Yeah.
Hello, sir.
Good evening.
All right, go ahead.
Yeah, I'm a bit confused about the placing of the different equipment in the expected position. It's a bit, I didn't get that clearly.
Okay.
Because if I'm asked to, I don't really know where to place what right now.
Okay.
You didn't give us example of equipments. You just said, the areas they can be placed. But can you give us example? Can you be more clearer?
Okay, no problem.
Thank
Let
you,
me
sir.
do that. I know that what we are doing on this table is just a summary of what we've been talking about. But like I said, the reliability center maintenance is a framework where you mismatch the different maintenance strategies so that at the end of the day, you get effective maintenance, effective equipment, and also you look at the cost, you reduce cost. For example, one of the elements in a reliability center maintenance, if you look at the first column there, it says corrective elements. For equipment with small parts and equipment, that's equipment with small parts, equipment, for example, say the light bulb now. The light bulb is an equipment or is an asset that you don't need to put around, you put a preventive maintenance around it. Because number one, they are small parts. They are, almost very not expensive, right? You can just, replace. If you say you want to put a preventive maintenance around that you say, okay, you need to employ a technician that you will be paying salary, and the technician will be going around your facility and be looking at all the bulbs in your facility and be checking that be cleaning them and be removing and doing one thing. You're going to spend more money and going to spend time. Instead of that, just leave it at run to failure. When the bulb, when you have a dead bulb, then you have to go and change. That's just it. Therefore, equipment that are non-critical, as in equipment that whether they are there or not, it doesn't affect, the core business. For example, in a room where you have AC, and in that same room you have a fan, that particular fan is non-critical. So you put it under corrective maintenance. If it goes bad, you go and fix it because it's not critical. It won't affect the core business. Do you understand? Are you there?
I'm here, sir. I can hear you.
Okay. No.
Thank you.
Do you understand? Okay. So
yes, it's clearer
under
now.
that again, we have equipment that is unlikely to fail. Let me give you an example of equipment that is unlikely to fail. Your, what's it called? Your microwave It's an equipment that can stay for a very long time, you know. So for such an equipment, it will be foolish for you to put a preventive maintenance around it, because it will be waste of money, waste of time, because it is an equipment that is unlikely to fail. Let's take the refrigerator too. These are equipment that can stay for a very long time before they go bad. All right. Then the last one is redundant equipment, something that you are almost not using. Are you going to put a preventive maintenance? It's not wise to put a preventive maintenance around that equipment. So reliability center maintenance is helping you to see equipment that you have, asset that you have, and how you can, you know, position them, how you can allocate resources to them, how you can now create a plan, your maintenance plan around them. Now, for the preventive elements, they now listed out what you'll be looking out for. Equipment subject to wear. Number one, when you say equipment subject to wear, you think of equipment that have what moving parts. For example, the generator, it has moving parts, so there will be wear and tear. So for such equipment, you use a predictive, what's it called, preventive maintenance, so that you put a schedule around it. Every 2 months, I carry out maintenance on that equipment, so that you'll be able to trap or replace that wear and tear. Equipment that has consumable parts, elements, consumable equipment, as in that has consumable parts. For example, what's it called? The filter, as in after use, you remove it, you put another one. When you finish using it, you remove it. Some equipment like that, they should be put under preventive maintenance. Then equipment with known failure patterns. If you have an equipment that you know how the equipment fails, for example, you have one AC in your facility, and you know that AC can only work for after 2 months. In the 3rd month, you must always carry out a kind of corrective maintenance on that AC. That kind of AC is for you to put it under a schedule of preventive maintenance. Then the manufacturer recommendations, which is very, very important. For every equipment, look at the manufacturer's recommendations. Then we look at the predictive elements. For example, equipment with random failure patterns, equipment that you don't really understand how it fails, right? For that kind of equipment, you use predictive maintenance. You look at the critical equipment. Critical equipment are equipment that, there are some equipment that once you carry out maintenance on them, they can never be the same again. It's just like all these K4, is it K5 televisions and all that, LED TVs. The moment you open them to say you want to carry out any kind of servicing or whatever, it can never be the same again. So equipment like that are critical, you leave it at predictive maintenance. So far you have the monitoring sensors and other things to monitor and to generate data for that equipment. Then you can now carry out maintenance based on the data generated. Otherwise, you leave it at run to failure, that when the equipment goes bad, when your TV goes bad, you go and fix it. But there's no kind of maintenance you can do around the TV. Equipment not subject to wear, of course, is not subject to wear. So you cannot really tell when it is bad. You need a monitoring device to monitor it, to know when it is bad for you to carry out maintenance. Systems which failure may be induced by incorrect preventive maintenance. Like I said, there are some TV sets that the moment you open them to do anything at all, that's the end of that TV. There are some equipment, the moment you start doing maintenance on it, that's the end. You can't get it right. So for equipment like that, you know, for example, our phones, maybe these tablets and everything, laptop and others, you can't you can't really do maintenance on them, because the moment you open them and you start fiddling with anything, you can't get it right. It can never be the same. So that's what Reliability Center does. So I don't know if your question has been answered.
Yes, sir.
All right.
It's much clearer now. Thank you, sir.
All right. So
sorry, I actually wanted to add to what she said. I mean, I wanted to ask maybe take it further, the question.
okay.
What I actually want to say, yeah, we have a maintenance plan where you have to, put all of this together when you are drawing up your maintenance plan. Now, most time, if you want to go by this the RCM, which is the Reliability Center Maintenance framework, how do you plot that in your of course you have to have an Excel where you have to put all of these things, which items or which equipment falls under the run to failure, the predictive, and also the preventive. So, and you want to marry this into, because what that means is that, what RCM in summary is that, putting one, two or more maintenance strategy together in order to achieve the your desire aim in terms of having having your facility to run properly, or equipment to run properly. So how do you put that when you are doing your maintenance plan? Are you going to say, okay, for instance, now, like you mentioned, the fan now, you have a fan in a room, you have an AC, you don't have to put the fan under for instance, now your run to failure or probably your preventive maintenance, as you may have with your AC, your air condition. So that one, you have to put it under your probably maybe run to failure. When it's when it's spoiled up, you have to take it for repairs and things like that. So how do you arrange that in your maintenance plan? For instance, you want to use those strategies together. How do you put that in? When you are presenting it, that you are adopting a reliability center maintenance framework. How do you put that together?
Okay, so
I don't know if you understand me. Yeah,
I'm just trying to understand you, but let me start from the very beginning. The first thing you want to do when you are given a facility to manage is to develop your asset register, right? And when you develop asset register, you are identifying all the assets in that facility. And the moment you are identifying all the assets, the next thing is to categorize the assets, to the different maintenance strategy. You can do that on an Excel sheet, depending on what you're using.
Okay.
If your organization have this CMMS, computerized maintenance management system, that will be even better, because it will help you to, arrange it. So you now categorize them based on their different strategy. If you have your generator already, definitely that will go under the preventive maintenance. Then you have your refrigerator will go under the run to failure, your pump run to failure. So when you categorize them now, you will now begin to allocate resources based on, the strategy. Now, remember that there are some generators that, apart from the preventive maintenance, if you want to optimize the functionality of that generator, you must introduce, in it some level of run to failure. There's some item there are some parts in that generator that you can tell yourself that, okay, for this particular part, we will put it on run to failure. That is, when it goes bad, we replace. But you must also know that it is not a critical, it must not be a critical part of that generator. Why are you doing this? You are trying to reduce the frequency of, changing of that particular part. You can put it under predictive maintenance if you have the resources to do that. So for that generator alone now, you have deployed the reliability centered maintenance. You have looked at it and say, okay, I want to place the generator under preventive maintenance. So they will do the regular routine maintenance after every 2 months. But for this particular component, because of its cost, we are going to, leave it at run to failure, as in when it goes bad, we remove and we replace. So that way you have deployed 2 strategies for just one asset. Do you understand what I'm saying?
Yes.
Okay, so
well.
what you are trying to do at the end of the day is that for that particular part, you just want to reduce the cost, because if you put it under routine maintenance, the person coming to maintain will change it, and that is money. But if you put it under run to failure or predictive maintenance, you only remove it when it is due. That way you have saved cost. So reliability center maintenance can look into your asset register. Number one, categorize them, your assets, into the different maintenance strategy. Then you can pick a big asset and say, okay, for this asset, what can I do to optimize my maintenance and also reduce cost? Then you begin to mix match the different strategy based on your experience and based on maybe your benchmarking with other organization, or what's it called now, best practices. Then you use that to build up your maintenance plan. Do you understand?
It's clear now, sir. Thank you very much.
All right. Before we go, I think that's the last slide before we go for assessment. Any other question so that we can just... So any other question? Anybody need a clarification?
Sir, is
anything?
Yes, is it possible to, because it's saying it sounds convincing, but it's a very difficult one for me as a person. Okay. So is it possible to get, like, under these various components? I know you gave us some example, but examples that can guide us to sort of come up with something that may look as if we are clear. I don't know about others. I'm speaking for myself. It's still a bit unclear to me.
What is unclear now? Let's get it. No.
How to categorize the equipment, because some of them might fall under more than one column here.
Yeah.
Like you rightly said.
Yes. Some of them can fall under more than one, but it is for you to know what you can implement based on your capacity and capacity of your organization. For example, predictive element is in fact, is the best, right? Is something that everybody wants to do. Nobody wants to carry out maintenance when it is not due. Everyone wants to carry out maintenance when it is due and at the right time. But how can you achieve that? You need a monitoring device to do that, right? But you don't have that. So what you need to do is to look at the others. For example, the like we said, run to failure. We already know for small equipment that are not significant, equipment that can easily be changed. So you don't need to make it elaborate. You don't need to think too much about it. For equipment that are small, you can just replace them without any stress, right? So for those equipment, you don't need to waste your time and to think about how to manage them, right?
Okay, so for example, now you are saying, let me use gardening tools for example.
Okay.
Gardening tools would be under run to failure.
Yes, run to failure.
Okay.
But if you have something like what's this thing? Motorized mower.
The motorized mower.
Yes, that you can now put under a preventive maintenance.
Preventive, yes. Okay.
Do you understand?
Okay. Yes, yes, I do now.
Okay.
Thank you, sir.
Yeah. So with this, you'll be able to, categorize your assets based on the maintenance strategy, and that way it will be very easy for you to allocate resources. It will also be very easy for you to come up with a robust budget that you can present, you know. All right, I think that's the end of it. So you go through the assessment questions, you answer them. If you have any thing you need clarification, you can reach out to us. We will, you know, and get back to you. So generally, what we have looked at today is the run to failure maintenance, a kind of maintenance that you just keep on, you just wait until, you know, there's a fault before you fix. That way you save yourself money, you save yourself employing people to come and do the work and all that. But again, it has its own disadvantage, because for critical equipment, for complex equipment, if you place them on run to failure, then you might crash the system. Then we look at the preventive element, the preventive maintenance for quick equipment that have moving parts, you know, consumable equipment that have known failure mode, that you can predict when the equipment will fail. So it's important you put it under predictive maintenance. Then for preventive maintenance. Then for predictive maintenance, this is the best kind of maintenance. But unfortunately, we do not have, you know, the resources to generate, to monitor the condition of our asset, to generate data, to analyze the data, and then come up with a conclusion or a recommendation as per that asset. So because of that, is a kind of a maintenance strategy that is still evolving. We believe that after some time in facilities management in the industry, we'll get to a point whereby we'll have a way of, you know, determining when to carry out maintenance so as to reduce the cost of facility management. All right, I think we'll have to stop right here. Thank you very much, and we'll see on Friday when we'll look at maintenance planning. On Friday, we are going to look at, we've talked about the different strategies. On Friday, we are going to look at the planning itself, how you plan your maintenance and why you must plan maintenance, and, you know, the result of a good plan. That's what we'll look at on Friday. And we'll also look at quality management system. What is quality to the FM? What is quality to the facilities manager? What is quality to the maintenance person? How do we achieve quality, customer satisfaction, and all that? So thank you very much. See you on Friday.
Thank you, sir.
Yeah.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Good night, sir.
Thank you,
Yeah.
sir.
Yeah.
God bless you,
Thank you.
Mr. Paul.
Yes, thank you, sir, for the teaching. I totally love today's teaching, sir.
All right.
Thank you, sir. Good night, sir.
Yeah, good night.